I'm Bill Crossley, Professor of Aerospace Engineering, and I'm here to answer your questions from the internet. This is Airplane Support. Yeah Boy Nath asks, why do commercial planes fly at 35,000 feet? So at about 35,000 feet, the air has less density, which means less drag, so you need less thrust to push the airplane through the air. However, the higher you get, the less density there is, the less thrust the engine can produce. So we try to balance the thrust the engine can produce with the drag on the airplane and try to find the best cruise altitude. It's around 35,000 feet. Onion Time E says, as a planologist, I have the know-how to explain the difference between models. For example, a 747 is 10 more plane than a 737. That's it, that's planes. It's kind of a humorous comment. So Boeing started with the 707, did the 727, then the 737, 747, 767, 777, and then 787. Some people think the number of the model means a bigger airplane. That's not actually true. It's just the order in which they came to market. Lockstrox asks, how does G-force work and what causes a pilot to pass out? So when you're flying in an airplane and the pilot pulls back on the stick to make the airplane go up, the people and the pilot sitting inside the airplane want to keep going in the same direction. But the plane pushes up on them. So while the plane is pushing up, all the blood is going to rush down. And that's what the G-forces are. How much that force is, number of G's, is relative to gravity. So I'm sitting here in my chair, it's 1 G. The pilot pulls back a little bit, maybe it's 2 G's max you'd ever see in a commercial airplane. Fighter pilots sometimes pull 4, 5, even 6 G's. That's what causes them to black out, is when that blood is running out from their brain into their feet and their legs. So how do we keep them from passing out? There's G suits that actually squeeze their legs to help keep the blood up in their head. And some pilots even learn tricks to grimace and scrunch themselves up to keep from passing out when they do high G maneuvers. Next up, Sentient Sadist says, don't try telling me that statistically airplanes are safer than cars. Well, statistically, they are safer than cars. The chances of you having a fatal accident in an airplane is something like 1 in 120 million trips, which is far safer than traveling by car or any other means of transport. Aviation has gotten safer and safer every single year. We've gone from having a couple of fatal accidents a year to recently having 1 every couple of years. There's been a huge improvement in safety. One of the reasons that they're safer is because the aviation industry, you've got 2 trained pilots. They've gone through lots of training on board. The aircraft have to be certified and are redundant systems, multiple things. So if one system fails, other ones back them up. And the whole air traffic management and air transport system is set up so that we know where the airplane is at all times and is staying away from other airplanes. So from a non-statistical point of view, all that extra stuff we do for aviation makes airplane flying safer than driving your car. Oof doof oof oof asks, what happens when there's a bird strike? Depends on how big the airplane is and how big the bird is and the relative mass of the 2 objects. Bird strikes have caused aircraft or helicopter windows to break. They sometimes get ingested into engines. We actually design the engines to handle a bird ingestion. One of the bird strikes that's probably most famous is the Miracle on the Hudson, where the Airbus ingested lots of geese into the engine, so both engines went out, and Captain Sullivan landed it on the Hudson River safely. It was a question from Noah Zavs. Landed at SFO. I still don't believe that airplanes can fly. I understand the science of it, but how can the wings generate that much lift? The simple answer is the shape of the wing, the speed of the airplane, and the angle of attack of the wing change the momentum of the air going past the airplane. It pushes down on the air, and the airplane pushes up. Creighton RSS asks, can a plane fly within 1 engine? Yes, it can. Actually, the way aircraft are designed, if you have more than 1 engine to be certified, they all have to be able to operate with 1 engine out. There's an interesting thing you've probably noticed in commercial aviation. Most of the airplanes operating today, commercial aircraft, only have 2 engines, even the ones flying across the ocean. 747 had 4 engines. That was because if 1 engine went out, you needed the 3 engines to get all the way to your destination or to come back to somewhere safe. As engines have gotten more reliable and more efficient and bigger, we're able to make aircraft with just 2 engines that can operate with 1 engine if one goes out to make it to a safe destination if one of the engines goes out. Tangerine Maximum 2976 asks, why is commercial aviation not improved in the last 50 years? It has improved quite a bit. I think one of the things that if you're looking at the airplanes don't look a whole lot different, but they have been improved a huge amount. They're much safer. The engines they use are much more reliable. We've moved from having multiple engines for transoceanic flights to having 2 engines for transoceanic flights. The electronics on the airplanes are much, much smaller, much more reliable. And so that makes the airplanes lighter. Our impact on the environment, because the airplanes are lighter and the engines are more efficient, has gone down a huge amount in the last 50 years. Airplanes are much quieter. When the airplane flies over you on approach to the airport, you hear it, but it's not the roar you used to hear from the older turbojet engines that look like skinny cigarettes underneath the wings. And now we got the big fat turbofans, which are much quieter. So commercial aviation has improved a huge amount in the last 50 years. The part about the air passengers experience, that's not the aerospace engineer, that's up to the airlines. That might not have improved much in the last 50 years. Next up, RGB says, what if airplanes were made of the same material black boxes are? Since black boxes generally survive plane crashes, the plane might be intact too. The black boxes are made of really strong material, but the really strong material is really heavy. And as aerospace engineers, we have to figure out what's the right material to be strong enough to do everything we need it to do, and be reliable enough to make many, many flights over its lifetime, but also be light enough for us to pick it up off the ground. Aircraft designers have settled on aluminum and composite fiber reinforced plastic are the two main things that aircraft are made of these days. HSN 407 asks, can I ask a flight attendant to change an empty seat? You always can ask the flight attendant. There's all kinds of reasons why you might not be allowed to. Airlines often use the different seats to generate revenue, so you might not be able to move to a seat you didn't pay for. On some airplanes, if there's not a whole lot of passengers on them, if you move to a different seat, you change how the weight is distributed in that airplane, and the pilots want you to be in a certain spot so that aircraft is easy to fly and stay safe. Viper says, hey, Aviation Twitter, I have a question for you. If both the pilots of a commercial airplane are compromised, can't air traffic control take remote control of the aircraft? The answer today is no, they can't, because they don't have the equipment on board. But actually, aerospace engineers have been working for quite a while to fly airplanes that have a lot of autonomous operations and are remotely piloted. The military regularly flies the Predator and Global Hawk without a pilot on board. The pilot or operator sits well off, and they can do that. To put this into commercial airlines would require a huge amount of upgrade to the equipment, and it'd be just an expensive endeavor at this point, not to mention the certification issues. Some new entrants in urban air mobility are pushing really hard at having more autonomous or perhaps even autonomous flights around a city where you don't have a pilot on board. That pilot would be remote. So this is coming. Now Minox asks, is severe turbulence really safe? At least from an airframe point of view, from the aircraft point of view, most of the turbulence will be rapid up and down accelerations. And so the airplane may drop and may climb during the turbulence, but it's usually you're so high in altitude, it's not going to throw you into the ground from a cruising altitude. There is a concern about something called wind shear. If you encounter that as you're coming close to an airport, that can actually push the airplane down. And there was a really well-known accident at Dallas-Fort Worth when an airplane hit this wind shear and it actually crashed short of the runway. We as an industry have put in sensors and better meteorological devices to make sure we're measuring so that if that's going on around the airport, we don't fly into that. Next up, Excedrin asks, do planes have an MPG gauge, which I think means miles per gallon? They sort of do, especially modern aircraft today. Fuel is such an expensive part of flying airplanes. A flight from Indianapolis to New York will require several thousand pounds of fuel for that flight. Airlines or anybody who operates an aircraft wants to use as little fuel as necessary. And so the computers on board can track how much fuel is being burned, what's the relative speed to the ground, and can suggest what's the speed the pilot should fly at to be flying at the best range possible. And that gives them the highest, quote, miles per gallon for the airplane. At the Trading Chick says, I'm not the best at science, but can one of my nerds let me know, would it be possible to make an electric airplane? If so, what would be the pros and cons? It is possible to make an electric airplane. And actually, there are a handful of electric airplanes actually out there already. There's some small trainer airplanes, 2 seats for people learning how to fly. Some of the pros are electric airplane cost a lot less to fly. Electricity is a lot cheaper than using jet fuel to fly an airplane, or using aviation gas for a smaller airplane. Another advantage is electric motors have a lot fewer moving parts, so the maintenance requirements are much lower, the reliability is much higher. The biggest con, batteries are heavy. We've gotten to the point where batteries are pretty good and we can use them for airplanes for short flights, but for long flights, the physics just doesn't work. We can't store enough energy in the battery. In an airplane that's using jet fuel, which is petroleum-based, not only is there a lot of energy in that, you burn it during the flight, so the airplane gets lighter as it flies. So if you're flying across the ocean, the airplane's a lot lighter than when it lands than when it takes off. And because it's burning that fuel, it means it's using less energy as you go along the distance. Clyde in Limbo asks, how do plane wings not snap or break more often? Well, it's because we do a good job designing them. When we design an airplane, we know about how many Gs, how strong a maneuver that airplane is ever going to be able to perform. And then we make sure that the wings are almost twice as strong as that maximum load that the airplane can put in. Just the aerodynamics of the airplane limits how many Gs you can pull, and then we design the wings to handle a load that's higher than that. And that's why they don't snap or break. Next one is from Cat's Eye 1. Can a science person please tell me how the driver of a plane can survive a noise vibration like a sonic boom? It literally scared the crap out of me. The pilot of the airplane won't actually feel the sonic boom. When an airplane starts to go at the speed of sound, the air starts to behave differently. I'm talking here in the studio, my vocal cords are making a pressure disturbance. That's getting picked up by the microphones. That's traveling at the speed of sound. The airplane has enough thrust, it tries to go faster than that, and essentially the molecules of air can't get out of the way. So instead, they pack together and the properties of those molecules as a whole change almost instantly. So right across the sonic boom, you have a change in pressure and temperature and density. Now what happens is that gets pushed out in front of the airplane. So if I take this airplane, which is a supersonic trainer, a Mach cone will form in front of the airplane. So the airplane won't actually be in the sonic boom. But that sonic boom will radiate down toward the ground, and that's probably what this person heard. And it does sound a lot like thunder. John Gunderman asks, can we bring back supersonic commercial flight? Pretty please? And the answer is yes, if you're willing to pay for it. It's very expensive to fly faster than the speed of sound. It's going to require a lot of extra thrust to push you that far. Extra thrust means extra fuel and bigger engines, more expensive airplane. Current commercial aircraft fly about 80% of the speed of sound or 85% of the speed of sound, while supersonic airplanes like the Concorde went almost 2 times the speed of sound. So you can see there's a huge difference in that speed. You're not allowed to fly faster than the speed of sound over land currently in the US or in Europe. If we can make that sonic boom a lot lower, we can actually fly supersonic over land, and it would make it much more profitable for the operator. Nervous Driver 334 asks, I'm not an expert, and then asks, but why can't airports have a ramp at the end of the runway like some aircraft carriers do? Well, the simple answer is aircraft carriers, people operating on those are Navy pilots, and if their airplane doesn't make it off the end of the runway, they know they're going into the drink. We can't do that with commercial aviation. We need the airplane to have enough runway that if the pilot's trying to take off and something goes wrong, he or she can step on the brakes, turn the engines off, put on the thrust reversers, and stop in time. The other reason is if an airplane's coming into land and something goes wrong on the landing, we need a lot of extra margin to allow everything possible to stop that airplane in time. Ralphie008 asks, why don't planes have parachutes? I've always been curious. Well, some airplanes do. This is a picture of a Cirrus SR-20. The Cirrus is a small single-engine airplane that was certified with a ballistic recovery system. If something goes wrong on the airplane, the pilot or somebody else with the pilot can actually pull a handle. It'll have a very small rocket that launches a parachute out, and that lets the airplane sink to the ground at a controlled rate, and people can get out of the accident. So small airplanes can have parachutes. The problem is the parachute needs to grow in size with the size of the airplane. So airplanes much bigger than something like that single-engine airplane, the parachute would be too big. It would take up too much room and be too heavy, so the airplane couldn't carry passengers or other goods. Primal Polly says, 50 years ago, the X-15 flew at Mach 6.7. No aircraft since then has ever gone as fast. But why? So first off, Mach 6.7 means that's 6.7 times the speed of sound. We would think of that as hypersonic flight, much, much faster than the speed of sound. This is an X-15. The X-15 was a research aircraft, and at the time we flew this, we needed a pilot on board to make sure it could do all of its operations. We used it to learn about what it takes to fly that fast and what happens to the aircraft and the flow around it going that quickly. Since then, we've actually flown aircraft or hypersonic vehicles that don't have pilots on board. The flight control system is good enough to do all those things, and we don't put a pilot in any jeopardy flying that fast. SMI 744-99326 says, it's true those jet engines produce a lot of thrust, and you will get sucked into them with no real problem. Unfortunately, that is true. There's been a few incidents where that's happened. Also, cargo containers have also been sucked into engines when they're turned on the ground. When you're at the airport, there's an area marked out usually where the airplane's parked at the gate, and there's usually a spot that's telling people on the ground, stay out of this area. Joey TV Show Season 2 asks, generally speaking, how much does it cost to build a plane? I don't actually know how much it costs to build a plane because the manufacturers usually keep that as a company secret. But I do know what the book price or listed price of an airplane is. The 787 costs about $300 million if you look on Boeing's website. The caveat to that is when Boeing sells their airplanes to customers, the airline might buy lots of airplanes and might work out a deal. So maybe like when you go to buy a car and you end up paying less than the sticker price, airlines often pay a lot less than the sticker price. But needless to say, commercial airliners cost hundreds of millions of dollars. Godwin Meter asks, how many hours of maintenance does his aircraft need for every flight hour? Actually, the number of maintenance hours per flight hour is an important metric for people who operate airplanes like airline pilots, or even if you own your own airplane, how long can you fly it before you need to go do some maintenance? Commercial airplanes go through all kinds of levels of maintenance depending on how many hours they've been flown. There's some simple checks where they just look through major systems and make sure there's nothing they see on a visual inspection, all the way up to a major overhaul where they almost take the airplane completely apart, look for any kind of problems, and put it back together to make sure that that airplane can last for 30 or 40 years. If you're waiting on a tarmac or you're waiting to board the airplane and you hear there's a maintenance issue, that's usually unscheduled maintenance. Those are in most cases very minor. Something like a light in the fasten seatbelt signs is out. They're not allowed to fly without that light working. At Trying to Do Right says, I wonder why we have an air traffic controller shortage. Do you have any theories? The airline industry continues to grow after the pandemic. We're at flight levels that were way above what we saw before the pandemic in 2020. There's just a need for aviation, and there aren't quite enough people to fill those positions. Another thing is a lot of people have been attracted recently to other jobs. Aerospace is really cool, and so I'm looking forward to teaching lots of students in my classes to get them in the aerospace industry. SSB Minifin asks, do planes need co-pilots, or is it purely a safety mechanism if something should happen to the first pilot? In modern aircraft, that's true. It really is a backup. It's being redundant. We still have pilots on the aircraft to make decisions about flying the airplane. But for most of the airplane flights these days, the pilots get to their cruise altitude and they allow the airplane to fly itself. And the pilots are on board to react to something that's unexpected or take control of air traffic control, ask them to go to a different altitude, etc. At Fly Lakeland ask, what's your favorite airplane? And my favorite airplane is the Lockheed Constellation. It's a World War II era aircraft that was designed by Lockheed. It became the first airplane that could successfully and reliably make it across the Atlantic Ocean. Not only do I think it's a cool looking airplane, I think it's a really neat airplane because it made the world smaller. And one of the reasons I like being an aerospace engineer is flying around the world makes the world smaller, and I think making the world smaller makes the world a better place. Thick Cactus 85 asks, how do jet engines work? We like to have a sort of a joke statement here in aerospace engineering. The jet engines suck, squeeze, bang, and blow. So this is a picture of a jet engine with the cowling or the nacelle taken off of it. The front end has a compressor. Well, at first it has an inlet. The inlet is the suck. That entrains the air into the engine. Then the compressor increases the pressure of the air. That adds more energy to it. Then we add fuel to that air and we combust it. In a combustor, that adds a lot of heat. So we've added a lot of energy to the flow. It passes past a turbine, which takes a little bit of the energy out to run the compressor. And then the shape of the nozzle at the back end of the jet engine makes sure we get the most push out of that exhaust. So we're basically increasing the momentum of the flow from what's in front of the engine to what's out that back. And that difference in momentum is what gives us the thrust. What I explained describes a turbojet engine. This picture is actually a turbofan engine. And this big part at the front is a fan. So in an engine like this, the turbine part of the engine, some of the energy goes to the compressor, some of it goes to turn this big fan. This big fan accelerates a lot of air that doesn't go through the combustor. That's more efficient than sending all the air through the combustor. You just can't fly as fast. Propellers are at the extreme end of that. Propellers can't go very fast, but they're even more efficient. That's it. That's all the questions I have. I hope you learned something. Until next time.